Hi, I'm Michelle Cohn, postdoc at UC Davis, and I'm presenting on behalf of our UC Davis KTH collaboration with PhD student Patrick Yonell and Professor Jonas Beskow at KTH, and on the UC Davis side, undergraduate researcher Taylor Kim and Professor George Zilu. And today I'll present our project, Embodiment and Gender Interact in Alignment to TTS Voices. Recently, advances in robotics and conversational AI have led to increasingly more human-like systems. We now have more human-like voices from household assistants like Google Assistant and Alexa, but there are also systems with expressive facial movements like Sophia and Furhat. So how do humans react to these more human-like forms? The Computers Are Social Actors, or CASA, framework would predict that we would engage with these systems like people. CASA proposes that humans apply social behavior norms from human-human interaction to their interactions with technology when they detect a cue of humanity in the system. For example, participants provided more positive social evaluations of a computer if the computer itself asked for the rating compared to when another computer asked, so kind of getting at human social norms of politeness. But is saying that we treat them the same way really the full story? Audience design theory proposes that interlocutors strategically adapt their productions for the perceived communicative needs of their listener. So people may have different communicative pressures when they're talking to computers, children, or hearing impaired individuals. So combining aspects of audience design and CASA, we ask if people's behavior towards voice AI systems vary gradiently, where we might predict that people will show more human social behaviors towards more human-like systems. And one way to get at this is by looking at alignment, when interlocutors adapt the features of each other's productions. And there's a literature examining alignment towards computers and humans. For example, Brannigan and colleagues found that participants aligned in syntactic structure for the dative, so give a bone to the dog versus give the dog a bone, to apparent humans and computers to the same extent in typed interactions. And this provides some support for CASA, that we're treating human and computers similarly. Other work has provided evidence for vocal alignment, so alignment in speech. So Bell and Gustafson found that museum goers aligned in rate toward an interactive computer avatar. In recent studies looking at voice AI assistants like Siri and Alexa, they have revealed differences for humans versus devices, with greater vocal alignment toward the human relative to the voice AI assistant. And furthermore, these alignment patterns were also socially mediated by gender. So they found more alignment toward male than female voices, both for the human and the TTS, or text-to-speech voices, similar to what's been found in studies of human-human alignment. And this is in line with communication accommodation theory, or CAT, that social factors shape this alignment. So again, for gender, but speakers can also use this degree of convergence to convey their social closeness or divergence to signal social greater distance based on how likable or attractive a speaker is. And we ask, is that also true for how human-like an interlocutor is? So combining aspects of audience design, CASA, and CAT, the present study tests whether people show different patterns of alignment based on gender. So here we're looking at male versus female asymmetries based on how human-like the system is. So on one end with the echo, which has no face, it's just a cylinder, the now in the middle, which has a face and a body, but then on the most human-like of the systems we used, the Furhat, which has a back projected video of a human face and moves to look at the interlocutor. So our first question is, will there be differences in vocal alignment along this line of personification? So one prediction is the more human-like, maybe the more vocal alignment. Alternatively, we might predict the opposite. So more human-like, maybe the less vocal alignment. And this would be in line with the uncanny valley. So here we've plotted kind of our three interlocutors. The x-axis is human likeness. On the y is familiarity, or sometimes likability. And we see that as you go closer and closer to human, people like it more and more. But at a certain point, when it approaches an actual person, this dips precipitously. So this is the uncanny valley. So this may be reflected in divergence patterns, possibly. Our second question is, are there differences in gender-mediated vocal alignment? Again, along this line. So one prediction is the more human-like, the more gender-mediated vocal alignment. So we might see stronger asymmetries of greater alignment toward the male versus the female voice. Okay. So experiment 1 consisted of 10 native English speakers. The stimuli consisted of 12 target words, all low-frequency items used in related work. And these were produced by two voices, which were presented, two identical voices presented across the 3 systems. And so those were Amazon Polly TTS voices. So the male voice was Matthew, female Sally, and these were US English voices. The experiment took place in a semi-soundproof room in the basement, KTH, Division of Speech, Music, and Hearing, and speakers wore a head-mounted microphone. You can kind of see our mixer there. So here are the parts of the experiment. So they started out first with some baseline production. So we want to know how they produce these words before they hear any of those interlocutors say them. And so we showed them several pseudo-randomized lists that they read from. So for example, list 1, list 2. After they began the shadowing procedure, so here we have the 3 interlocutors, and so which one they started with was counterbalanced across subject. And then for any given subject, they had a single gender ordering. So it was always male, female, etc., or female, male, etc. This was to avoid consecutively presenting the identical voice. So here's kind of what it looks like. Here's Patrick during our demo. So here he's sitting at the now station. Basically, we made 3 stations around the table. So the participant still plugged into their mic was able to get up and sit at the different stations according to their counterbalanced order. So here talking to the now, the fur hat, and the echo. So once they got to one of those stations, it started with a brief introduction, including a name. You'll see an example of that. Each one went through the task, and then they did the word shadowing portion, the 12 words, 2 repetitions. So let's see what that looked like.
Hi, I'm Rebecca. I'm a social robot. Today we're going to do a task together. First, I'll say a word. Then, your task is to simply repeat after me. When you're ready to start, say begin.
And then they did the shadowing portion. Here's an example word.
Chime.
Hi, I'm Matthew. I'm a social robot. Today we're going to do a task together. First, I'll say a word. Then, your task is to simply repeat after me. When you're ready to start, say start.
Here's an example word from the male speaker.
Chime.
Okay, and then same thing for the now. Again, the same voices.
Chime.
Chime.
Again, the same female voice, and then the male voice.
Chime.
Chime.
After they did some ratings for each of the interlocutors, I'm not going to go through that now just because of time constraints, but there are some interesting interactions there with alignment in the paper if you're interested. Okay, experiment 2. So we had 51 native English speakers from UC Davis, and the stimuli consisted of the productions from the first experiment, the word shadowing. And we had to exclude 4 of those words. Remember, there's 12 words, just because a lot of speakers mispronounced words like wren, and yawn was very ambiguous. But this was fine because it left us with a total of 480 tokens that we could test. So this listening experiment was conducted at UC Davis in a sound attenuated booth. Participants wore headphones, and then they were facing a labeled button box like this. And then they were told, in this experiment, you'll hear 3 words in a row. A and B are by the same person and X is a different person. And their task is to judge whether A or B sounds most like X. On the back end, A and B are the same speakers, but one is the pre-exposure, so when we collected that baseline production before the shadowing, and then one is the way they produced chime after they heard it produced by fur hat. The idea being this post-exposure, if alignment is occurring, will sound more similar to the fur hat. So here you can see one in action. This isn't from our exact study, but it's a similar setup. So then we coded their responses. So if they did indeed choose the post-exposure, and again, this was balanced counter by speaker and by word, so pre-exposure wasn't always first. So if they selected post-exposure, we coded that with a 1, otherwise a 0. And then we modeled that with a logistic regression with main effects of model talker system, echo, now, for hat, model talker gender, shadow gender. So we added that since it was shown to also be a mediating factor in alignment in other studies. And then random effects, including random intercepts for word, rater, so the listener part, as well as the actual shadower. All right, what did we find? So on the x-axis is the model talker system, echo, now, for hat. On the y is perceived alignment from that perception study. So this is the proportion of trials where they selected that post-exposure, sounding more similar. On the left, female shadowers, on the right, male. And then the colors indicate the different TTS voices. So if it was the female voice or the male voice. Female voice in orange, male voice in blue. All right, so now we can see everything. So we're gonna go through the results piece by piece. So we found a main effect of model talker gender, where we see greater alignment towards the male in blue than female overall. There was no main effect of model talker system, but it interacted with gender quite a bit. So we found that males and females aligned more to the male now than the female now. So you can see that here. There was also a 3-way interaction with shadower. So females align more to the female fur hat. You can see that there. And less to the female echo. So really giving kind of a line here. We re-leveled the model to look at what was happening with males, and we found that males aligned more to the male fur hat. You can see that there. And less to the echo. But then we did a post hoc analysis just to see if the alignment toward the male fur hat and now were different. They weren't different, but they were both higher than for echo. Okay, so overview. So what did we find? We found some alignment for all voices in all forms, all embodiments. So here in green, I marked chance. So everything is higher than chance. We saw no divergence. That we see alignment is in line with other studies of isolated word shadowing for Siri and Alexa in our lab. We also saw more alignment towards male versus female TTS voices. So again, that provides support for cat that we are seeing these socially mediated patterns of alignment. We didn't see a main effect of model talker system, but there were many interactions between model talker gender of model talker system with model talker gender and shadower gender. So if we kind of take a zoomed out approach, we could kind of see that female shadowers, so on the left, kind of display more gradient alignment towards female TTS voices. So it's kind of like increasing alignment towards fur hat from echo. Whereas this pattern seems to be a little bit more categorical for males. So less for echo, but then kind of the same for the male TTS voices presented in the now and fur hat. So overall, this suggests a dynamic interplay between social and cognitive factors, things like personification and gender, as well as multiple theories. And it leaves many avenues for future work to probe these interactions. So you could have a more or less competent interlocutor that could kind of get at audience design a little more. Of course, more types of voices, more voices would be great. And other social categories can also further test how these factors interact. So thank you to our KTH UC Davis team, seen here. Thank you also to Fur Hat Robotics for loaning us a fur hat for a week. Thanks to our participants and our UC Davis undergrad RA, Irene Ho. Thank you.